This is CPM Precalculus Chapter 2, number 127. So here we're asked to write down the sums, again, just the sums, but do not add them up, that you would use to estimate the area. So the area is going to be between our x-axis and the curve 2 to the x, between 1 and 4, using 6 intervals, all right? So part A, we're asked to do left-hand endpoints. So this is where we're asked to do rectangles, right? All right, so what we should do first always is go ahead and graph our function that we're finding the area between those regions. So let me use the calculator graphing tool, y is equal to 2 to the x, just to kind of show me. Let me zoom standard because, oh, there it is, but let's zoom standard so we can see it a little better. Okay, and so I see that my graph looks like this, and it's going up to the left, right? Left and right here, and we're going from 1 to 4, and we're trying to estimate the area in between this region. So this is y is equal to 2 to the x, and then we're looking between 1 and 4. All right, so looking at left-hand endpoints, right? Again, what we need to know is, well, 6 intervals, what is going to be our width? So our width is going to be just b minus a over n, and we're going from 1 to 4, so b is 4, a is 1, and n is 6. Okay, so that is just 4 minus 1 is 3 over 6 is 0.5. All right, so I know the width of each region is 0.5, right? And then the area I'm basically going to estimate is going to be the area of my function 2 to the x between 1 and 4. I know I'm just going to multiply to get rectangles, the base times the height, the base times the height, the base times the height for each of these rectangles, 6 of them. I know the width is 0.5 every time, and the height starts at 1, right? At x is 1, so it's 2 to the 1 power. So this is my first rectangle's area. My second one is the same base times the second one is going to be 1 plus the width, so it's 1.5 is my x value, plus 0.5 times 2 to the power of, we're adding 1.5 and 0.5, so that's 2.0, plus 0.5 times 2 to the, we're adding 0.5 to the 2.0, 2.5. Again, the next rectangle is 2, and we're adding to the power 0.5, so 3.0. And this is 1, 2, 3, 4, 5. We have 6 rectangles, so one more, 0.5 times 2 to the 3.5 power. Okay? So this is basically what I'm adding up to get my sum. I'm not going to add them up, so I'm just going to leave it like this. Okay? I can go ahead and simplify this if I want by factoring out the 0.5, and it's 2 to the 1 plus 2 to the 1.5 plus 2 to the 2.0 plus 2 to the 2.5 plus 2 to the 3.0 plus 2 to the 3.5, right? And I've done this enough that without needing to go ahead and graph it, I can already know that this is the area that I'm going to be calculating using left-hand endpoints. Okay, so let's go on to part B, and that's using right-hand endpoints. Again, that's rectangles, right? But this time, instead of starting at 1, we're going to start with the right side of the first region. The width is still b minus a over n, or 4 minus 1 over 6 intervals, right? Which is 3 over 6, or 0.5. So we still have the same width. Okay, so then the area using right-hand endpoints for our rectangles between 1 and 4 is going to be, the base is 0.5 again, and the height now, we're going to start with the height not at x is 1, but at x is 1.5. So we're going to start at 2. So our formula is 2 to the x, so it's 2 to the 1.5 power. And then we're going to add in the next rectangles, 0.5 times 2 to the 2.0 power. We're still adding the width each time, right? Plus 0.5. Okay? Plus the next rectangle is 0.5 times 2 to the 2.5 plus 0.5 times 2 to the 3.0, right? All we're changing here is the exponent, and it's adding 0.5 each time, plus 0.5 times 2 to the 3.5. And this is 1, 2, 3, 4, 5 rectangles. We need 6, so one more, 0.5 times 2 to the 4.0. Okay? Again, I can factor out the 0.5 if I want, and it's going to be 2 to the 1.5 power plus 2 to the 2.0 power plus 2 to the 2.5 power plus 2 to the 3.0 power plus 2 to the 3.5 power plus 2 to the 4.0 power, right? So do not add them up. So we are done here finding the sum for our right-hand endpoint rectangles. All right, part C is looking at trapezoids. And remember, when we have a trapezoid, we have a base here, we'll call it base 1, and a base here, called base 2, and the distance between them, because these bases are perpendicular, is the height. So the area of this trapezoid, is 1/2 adding the bases and multiplying by the height. So it's 1/2 base 1 plus base 2 times the height. So the area then is going to be, that we're looking at, of our function between 1 and 4. Okay, we have 6 intervals. So this distance, this height now, is going to be the width, right? So the width, again, is b minus a over n, which is 4 minus 1 over n is 6, which is 0.5. So we know that that's equal to h here, okay? So I'm going to be adding in 6 trapezoids this time. So it's going to be 1/2 times base 1. Well, base 1 is going to be the height of my rectangle at x is 1, right? So it's 2 to the 1 power. Plus base 2 is going to be the height of my rectangle at the next point is going to be, we're adding 1.5 each time, is 2 to the 1.5 power. Times the height, we know is 0.5, right? So this is the first trapezoid. So we have 6 of those trapezoids, 1/2 times the next trapezoid again starts where the other one has the same base on the left side now, right? So they share, this one shares one base with this one, just like every trapezoid, because they're connected, right, is going to share a base with the next trapezoid we're finding the area for. So this is 2 to the 1.5 power plus the one we're always going to be adding, right, 0.5, which is the width. So this is 1.5 plus 0.5 is 2 to the 2.0 power times the height. Remember, we're looking at the area of a trapezoid. The height we know is 0.5 plus the next trapezoid starts off with this same base, 2 to the 2.0. The distance of 0.5 makes this 2 to the 2.5 times the height is 0.5. That's the third trapezoid. The fourth one again starts here. It shares that base, 2 to the 2.5, plus the next base is going to be 0.5 away, so it's 3.0 times the height, plus the next trapezoid is 1/2 base 1 plus base 2, so it's 2 to the 3.0 plus 2 to the 3.5 times 0.5, right? So we have 1, 2, 3, 4, 5 trapezoids so far. We want 6 trapezoids. So the last one's going to be 1/2 times shares a base here, 2 to the 3.5 plus 2 to the 4.0 times 0.5. Okay, so these are our 6 trapezoids we're finding the area for. We can go ahead and simplify this, let's factor out the 1/2 and the 0.5, right? And we're left with in here 2 to the 1 plus 2 to the 1.5 from this, plus 2 to the 1.5 plus 2 to the 2.0 from this one, plus 2 to the 2.0 plus 2 to the 2.5 from this one, plus 2 to the 2.5 plus 2 to the 3.0 from this trapezoid, plus 2 to the 3.0 plus 2 to the 3.5 from this trapezoid, and finally 2 to the 3.5 plus 2 to the 4.0 from this trapezoid. Close that off. Okay, and we see we have 2 of each of these, right? So I can go ahead and say, well, that's 1/2. I'm just basically simplifying this. We have 2 to the 1 plus 2 of these means we have 2 times 2 to the 1.5 plus 2 of these means we have 2 times 2 to the 2.0 plus 2 of these means we have 2 times 2 to the 2.5 plus again 2 of those, 2 times 2 to the 3.0 plus 2 of these, 2 times 2 to the 3.5, and only one of these, so it's plus 2 to the 4.0. Right, we have 2 times all of them except for the ones on the end. Okay, and let's just simplify this even more. That's 1/2 times 0.5 on the outside. On the inside here, we have 2 to the 1 plus, we can add these to, we can combine this, right? Because this is 2 to the 1 with the same base, we just add the exponents. So that's 2 to the 2.5 plus, add the exponents. 1 plus 2 means 2 to the 3.0. Add the exponents. 2 to the 3.5 plus add the exponents. 2 to the 4.0 plus add the exponents. 2 to the 4.5 plus 2 to the 4.0. Alright? I can even combine these two now. This is just like simplifying it for fun. 0.5, 2 to the 1 plus 2 to the 2.5 plus 2 to the 3.0 plus 2 to the 3.5 plus, now I have 2 of these, so I'm going to write them last. So let's write this one first. 2 to the 4.5 plus, and I have 2 of these, so I'm going to just say 2 times 2 to the 4.0, right? And that's the same as 2 to the 1 times 2 to the 4.0, which is the same as 2 to the 5.0, right? So let's go ahead and write it as 2 to the 5.0, right? And that's combined from these two here, right? And they make 2 to the 5.0. All right, so that was just simplifying this for fun. When this question asked us to go ahead and write down the sums, so any of these lines are okay. We could have stopped here, we could have stopped here, right? We could have stopped here, or we could keep going and stop here, because we're not really adding them up, we're just simplifying this, right? So what do we notice? I guess the interesting to note is that we're adding, for a trapezoid, we're adding in this half in front, right? For the rectangles, we didn't have this half, but we're also multiplying like 2 of each of these, right? Or we're adding in the height twice, or the base length twice. We have 2 2.0s, 2 of these, 2 of these, 2 of these, and 1 on the ends. So that's just something to notice when we're doing trapezoids. We are looking at, again, 2 sides, so we call them base 1 and base 2, and the height in between them, right? And the sides here, the bases are parallel, and that's our trapezoid. And so we're going to start to look at, like, trapezoids give a better approximation of the area when our curves like take this form, like take a form like this, because trapezoids basically are looking at the average, if you want to look at it later, of the left and right hand endpoint rectangles. Okay, so we should look at that later, but a trapezoid is equal to the average of these two rectangles, right? Add them together, the area, and divide by 2, and you get the area formed by just one trapezoid. Okay? Anyway, that's beyond the question scope. So this ends for us chapter 2 of CPM Precalculus number 127.